In today's video, I will discuss some cases to find tension. Otherwise, to finding tension is not that tough because you have to make free body diagram and find the tension. But there are some tricky areas that only I will discuss today. I am Datta sir. I am making this type of videos regularly. I am an ex-senior professor of a number one IIT JEE Institute of India, and I have been teaching IIT JEE students for a long time. I have seen that although most of the students, they go through various concepts, they do not know some tricky areas because they feel they face confusion about it. That's why I am making this type of video. If you are one of them, please listen to this very carefully. So I am going to the topic. Here we will find tension in three different cases and I will tell you the trick. In first case, suppose there are two blocks on a frictionless ground and they are tied with a rope, massless rope, and one force F, horizontal force, is acting on the block capital M. Now with this force, the total mass system consisting of two masses will move forward with an acceleration. Now if we have to find the tension in the string, what we will do? We have to make free body diagram. So in such cases, we will do one thing. Please note carefully. At first, we will consider the two bodies as a whole as a system. So their combined mass is m plus m, and then tension becomes internal force, and the external force only is F acting on the system. So therefore, we can write the equation F equal to m plus m into capital A. That is, A becomes F by m plus m. So this is the first step. So first step, we consider both masses as one system and find out the acceleration. In the second equation, we can either take capital M individually or take small m individually. But I have taken small m. Why? You see, if I take capital M, we have to use two forces. One F in the front direction, another T in the back direction. So in that case, the equation will be a bit lengthier. So what we do, we take the mass which is further away from the external force. That means we take small m. If we take small m, then equation becomes very easy because on small m there is only one force, that is T, and simply we write T equal to ma. And A already we have found out, so we write T equal to m into capital F by m plus m. So it takes you only two lines to solve the problem. If we take capital M, then you will need another line. That means slightly lengthier. So naturally in any examination, time is short, so we have to think which is easier. So this is on tip, that we consider the block distant from external force. Here it is small m. Same thing happens, suppose I am taking another example. Two blocks, capital and small m is lying on capital M, and by one force applied on capital M, they are moving together on a frictionless surface. Here again, in between them there is a frictional force, and one force is acting on capital M, that is backward, and on the one force equal and opposite friction force is acting on small m forward. That means friction is acting for capital M backward, for small m forward. Here also we will apply the same method. First we will take both the mass as one system and we will write F equal to m plus m into A, and we will find A equal to capital F by m plus m. And then we will take the mass which is away from the here nearer mass is capital M and distant mass is small m. So I am taking small m because in that case small m has only one force acting on it, that is frictional force forward. So for small m we can easily write small m equal to ma, small m into a. That means f equal to ma. So that means f becomes m into capital F by m plus m. So very easily we can find out. So here also we consider the block distant from capital F. Considering other block will also be okay, but here there we will have an extra step, extra line for that. So that is the general rule you can use. Same thing we can use in case of a rod. Suppose there is a rod of length capital M, L, and mass capital M. Now a force capital F is applied on the rod and rod is on a frictionless table or frictionless ground. Now by the force, the mass, the rod is having an acceleration definitely. Now if we are asked that at a particular point P within the rod we have to find tension, what we will do? So here what we will do is we will mentally divide the rod into two parts. One part backward of point P, another part in the front side of point P. Backward part, let us say its distance is x. So forward part is distance L minus x. Now we can apply the same principle as we applied in earlier two problems. There what we did, first we took the entire mass and found out acceleration. Then we took the distant mass and applied this. So here also we have converted the rod into two parts and the two parts may be treated as two blocks as earlier and tension in between will be there. So here also if we take the whole mass we can write F equal to capital M into A, F equal to capital M into A, so that A we can write capital F by M. Now the mass of the rear part will be by unitary method capital M by L into X. So we can tell it as small m. Now we can take the front part also, but then we will, as I told, then we will have to use one more line. That's why we will take the distant part. Distant part is AP. So its mass is capital M into X by L. So we have already written F equal to MA, A equal to F by M. Now rear part, the only force that is pulling it is tension. We can write T equal to small m into A. It is capital M into X by L into A. And if we put the value of A, it becomes capital X M into X by L into F by M. So that it becomes F into X by L. So that is the tension at the point P, F into X by L. So you see that tension is dependent on X. F is a constant, capital L is a constant, but X is variable. As the X increases, the tension increases. If X is less, tension is less. That means as the P point moves towards B, the tension increases. At the P point moves towards A, tension decreases. And when P point is at A, that means at the end A, tension becomes 0. And at the end B, then X becomes L. So tension becomes T into F by L into L, means T equal to F. So that is the maximum tension. So in the rod, tension will be maximum in B end and minimum 0 at A end, and in between the tension will be continuously increasing. And we have solved this problem by the same way as we solved the problem of two blocks. So this is the principle I wanted to tell you. Means we consider the part distance from F. It can be done by considering other part also, then we will involve another line. So this was the concept I wanted to give you today. I hope you have understood this. Please go through this again and again and try to understand this trick. If you are benefited by this video, please like this video, share this as much as you can, and also you subscribe to my channel, because in my channel I will keep bringing you new concepts of IIT JEE. And also please let me know your comment so that I can know that what is your requirement, then I can bring any new video on that concept. So thank you very much for today. I will bring another concept in my next video.